You know that feeling, right? You're just scrolling, clicking links, jumping from site to site.
Yeah, finding exactly what you need in, like, seconds.
Exactly. The web is just there. It's fundamental to pretty much everything we do now.
Mm-hmm.
But can you imagine a world where sharing information, like globally, was incredibly difficult, fragmented, stuck in different systems?
It's almost impossible to picture now, isn't it? But yeah, that was the reality not that long ago.
And the transformation, getting us to this instant global flow, well, it largely comes down to one person's vision.
Uh-huh. Sir Tim Berners-Lee.
That's exactly who we're diving deep on today. So Tim Berners-Lee, the inventor of the World Wide Web.
Yeah.
We've gone through, well, a whole stack of sources, articles, biographies, lots of historical accounts, trying to trace his journey, understand the problem he was trying to solve.
And also looking at what he's doing now, his ongoing efforts to shape the web's future.
Right. Our goal here is to pull out those essential insights, maybe some surprising facts, and really connect the dots. How did one guy fundamentally change how the world shares information?
Think of this as your shortcut, maybe, to really getting the origins and the man behind, well, the digital curtain you use every single day.
Okay, let's jump in. Let's unpack the story behind something you use probably nonstop.
So where does the story even begin? It starts in London, June 8, 1955. Tim Berners-Lee is born.
Okay.
But his background wasn't exactly typical.
Right, let's unpack that a bit. Our sources really highlight his parents, Conway Berners-Lee and Mary Lee Woods. What was so special about them?
Well, they were both mathematicians and computer scientists.
Okay.
And not just any computer scientists. They actually worked on the Ferranti Mark I.
The Ferranti Mark I. Wasn't that one of the very first commercial computers?
One of the absolute first, yeah. So super early days of computing.
Wow, that feels significant. I mean, working on one of the earliest practical computers, how do you think that kind of early exposure might have influenced him?
Well, it seems like it really set the stage, where computers weren't just these abstract machines, but actual tools for solving problems, handling information. And you kind of see this practical bent even in his childhood hobbies. Like, he was apparently a keen train spotter.
Okay.
And he learned electronics by tinkering with the model railway set.
Huh. I love that detail.
Yeah.
Model trains leading to the World Wide Web.
Yeah.
So did that hands-on approach continue when he went to university?
Oh, absolutely. He studied physics at Oxford, the Queen's College.
Right.
And while he was there, showing that same, tinkering spirit, he actually built his first computer.
Built it himself.
Yeah. From spare parts, he kind of scavenged. An old television, soldering iron, some basic electronic gates, a processor.
That's some serious dedication. So after Oxford, what was his early career path? Did it lead him towards these kinds of information problems?
Yeah, step by step. He worked as an engineer first at a telecom company called Plessey.
Okay.
Then he moved to a place called DG Nash. There he helped create typesetting software.
Typesetting.
Okay. But importantly, while he was there, he also got experience with a project involving something called a real-time remote procedure call.
Remote procedure call. Sounds pretty technical. What's that in plain English, and why was it important?
Basically, think of it as getting different computers to talk to each other directly, like remotely execute commands.
Got
So it gave him real hands-on experience with that fundamental challenge, getting information to flow between separate machines, which is, totally central to networking and eventually the web.
Okay, so he's got this unique background, physics, practical electronics, tinkering, some networking experience. Where did he take all that next?
Right. That brings us to CERN, the European Particle Physics Laboratory in Geneva.
CERN, okay. Big physics research center.
Exactly. He first worked there in 1980, just as an independent contractor. Then he came back in 1984. And it was in that environment at CERN that this growing problem became really impossible to ignore.
What was the specific challenge they were facing there?
Well, imagine thousands of researchers, right, from universities, labs all over the world, collaborating on these huge, complex physics experiments.
Yeah.
They were generating massive amounts of data, documents, everything, but sharing it, accessing it, that was incredibly difficult.
Why? What was the issue?
The information was just fragmented. It was stuck on different computer systems, used different formats. It was, well, a bit of a mess.
So the information existed, but it was all locked away in different silos, hard to find and connect.
Precisely. And he actually saw this problem during that first stint back in 1980.
Okay.
And even then, he proposed this idea for a global system based on hypertext, the idea of linking documents together just to manage information better.
Hypertext.
linking things.
Yeah, he even built a little prototype system back then, called it Inquire.
Inquire, like inquire, asking for info. Seems fitting. But the real spark, the idea for the web as we know it, that happened later.
Yes, the pivotal moment really came when he returned to CERN in 1989.
Okay, what was different then?
Well, CERN by then was a major hub on the existing internet, the network connecting research institutions.
Right, the internet existed, but it wasn't the web.
Exactly. And he saw the opportunity. He could combine his earlier hypertext idea with the power of this existing network. He actually said he wanted to marry up hypertext with the internet.
That sounds like the aha moment. So what did he propose to CERN? How did he pitch this?
In March 1989, he wrote this paper, Information Management, a proposal, laid out the system.
And how was it received?
Famously, his manager at the time, Mike Sendall, wrote on the cover, "Vague but exciting."
Vague but exciting. Talk about an understatement in hindsight.
Totally. And Berners-Lee himself, he described the whole idea later as kind of an act of desperation.
Desperation? Why desperate?
Well, he felt the existing situation was just so difficult, so inefficient for the researchers, something radical had to be done.
Okay.
And he realized that most of the pieces he needed actually already existed. Hypertext was a concept, the internet was there, displaying text and images was possible.
So it wasn't about inventing totally new core technologies.
Not entirely, no. His key insight was seeing how to connect them. Thinking at a, as he put it, higher level of abstraction. Seeing how they could fit together to create this seamless information space.
Right. Combining existing ideas in a new way.
Exactly. And it's worth mentioning, he wasn't totally alone in pushing this at CERN. Another researcher, Robert Kallio, had independently come up with similar ideas about a hypertext system there.
Okay.
And Kallio became a really key partner, helping Berners-Lee champion the project and get it off the ground.
So the concept's clear. He's got a partner. What were the first concrete steps? What did he actually build?
Well, he had to create the basic software tools, right? So he wrote the very first web browser.
The first browser ever.
Yep. He called it World Wide Web. Actually, it was kind of unique because it was also an editor. You could create pages with it too, not just view them.
Oh, interesting. An editor and browser in one.
Yeah. And alongside that, he built the first web server, the software that actually stores and sends out the web pages. That was called CERN HTTPD.
Okay, so browser and server software.
Right.
But beyond the programs, he needed the rules, the language for them to talk, right?
Yes, absolutely critical. He invented the fundamental protocols and formats that we still basically use today.
Like what?
HTTP, the Hypertext Transfer Protocol. That's the language browsers and servers use to communicate.
Okay.
HTML, the hypertext markup language, that's the code used to actually structure the web pages, tell the browser what's a heading, what's a paragraph, etc.
Right.
And the URL system, the Uniform Resource Locator, that universal address format for finding anything on the web.
HTTP, HTML, URL, the absolute bedrock.
Bedrock. And of course, they were refined over time as the web grew, but he laid that foundation.
So what was the very first thing he put online using all these new tools? What did the first website look like?
The first website was at info.cern.ch. It went live internally at CERN, December 20, 1990.
Okay, just inside CERN first.
Yeah, basically explaining the project. But then, and this is crucial, he announced it publicly, put a post out on Usenet, like an early internet forum system, on August 6, 1991.
Right, opening it up.
Yeah, inviting the world to try it out. The site itself was pretty simple. It just explained what the World Wide Web was and gave instructions on how others could set up their own servers or get the browser software.
Helping others get involved.
Yeah.
And that really leads us to maybe the single most important decision he made, doesn't it? The one that really let this thing explode.
Oh, absolutely. The masterstroke, really. He decided to make the whole thing, the idea, the code for the server and browser, the protocols, completely freely available.
No patent, no royalties, no license fees.
Nothing. Just open. Put it out there for anyone to use, modify, build upon.
That must have been incredibly countercultural for tech back then.
Totally. I mean, imagine if you had to pay a license fee just to create a website or build a browser. It would have been completely different.
Yeah.
That single decision was absolutely key to its rapid, decentralized, explosive growth. Anyone, anywhere could build on it.
And explosive growth really feels like an understatement, doesn't it? The web just took off like nothing else.
Oh, yeah. Sources call it the fastest growing communications medium of all time. It fundamentally reshaped, well, everything, modern life. Instant global connection, access to information.
Mm-hmm.
It got so big that one source mentioned a panel in 2016 ranked the invention of the web as the #1 cultural moment. period.
Wow. Number one. But with that kind of crazy growth, keeping it all working together, keeping it from fragmenting or being, taken over by competing commercial interests, that must become a huge challenge.
It did, absolutely. And to try and manage that, in 1994, Berners-Lee founded the World Wide Web Consortium, the W3C.
The W3C, right, I've heard of them, hosted at MIT.
Hosted at MIT, yeah. And its whole purpose was, and still is, to develop common standards and recommendations for the web.
To keep everyone on the same page, technically speaking.
Exactly. And crucially, to ensure those standards remained based on royalty-free technology, to preserve that fundamental openness he'd established from the start. He's actually been the director ever since.
But his efforts to kind of guide the web didn't stop just with the technical standards, did they?
No, definitely not. He recognized its huge societal impact. So in 2009, he co-founded the World Wide Web Foundation, the WWWF.
Okay, the WWWF. What's their focus?
Their mission is much broader. It's about ensuring the web serves humanity, establishing it as a global public good, advocating for things like access for everyone, digital rights.
More the social and political side of the web.
Right. And alongside that, he's also been a massive advocate for open data.
Open data?
Yeah, he co-founded the Open Data Institute, the ODI, in 2012.
What's the idea there?
Promoting the idea that non-sensitive data, especially from governments and public organizations, should be freely available online for anyone to access, use, and build upon. He was involved in initiatives like data.gov.uk in the UK, arguing basically that information should be public unless there's a really good reason for it not to be. Privacy, security, that sort of thing.
And supporting related ideas like linked data, too.
Yes, very much so. The idea of making the data itself interconnected and understandable by computers, not just documents linking to other documents.
So alongside founding these organizations, he's kept up his academic work, too. MIT, Oxford.
Yep, holds posts at both. At MIT's CL, he leads the Decentralized Information Group DIG, which we'll come back to, and he has a position at Oxford's Computer Science Department.
It really seems like his role evolved, didn't it? From inventor to almost a global steward for the web.
That's a great way to put it, yeah. He's constantly working to address the challenges the web faces, often because of its incredible success and scale.
Like what kind of challenges?
Well, for instance, he's been a really fierce advocate for net neutrality.
Net neutrality, right. The idea that Internet service providers, ISPs, should treat all data equally. No fast lanes, no blocking. Why is that so important to him?
He views it as a fundamental human network right. His argument is pretty straightforward. ISPs shouldn't get to control or slow down or monitor what you do online without your explicit okay. It's about preserving that open, level playing field that the web was originally built on. He even signed a big open letter to the FCC back in 2017, urging them not to repeal the net neutrality rules in the U.S.
It feels like his constant focus is maintaining the web as this truly open, universal space for everyone.
Largely, yes. That seems to be the driving force. Though, as the web matured, some really complex issues came up that kind of challenged that pure ideal.
Okay, like what?
Well, one example our sources point to, which was pretty controversial, was his stance on something called encrypted media extensions, or EME.
EME, encrypted media extensions. What did that do?
Basically, it's a web standard that allows content providers, like streaming services, to use digital rights management DRM technology within the web browser itself.
DRM, copy protection, basically. Why was that controversial in a web context?
Well, opponents groups like the Electronic Frontier Foundation, the Free Software Foundation, defective by design, they were really concerned.
About what specifically?
They worried that EME could undermine the web's universality. The fear was it could lead to situations where you have to use a specific browser, maybe one that's less open or not great for privacy, just because a content company mandates it through DRM instead of the content just working in any standards-compliant browser.
Right, so a potential crack in that this is for everyone's foundation, locking content to specific platforms via the browser.
That was exactly the fear. And our sources note that Berners-Lee, he was initially kind of neutral on it, but in 2017 he ultimately supported the proposal, feeling it was somewhat inevitable maybe, and he approved the final W3C specification.
Despite the opposition.
Despite significant opposition, yeah. It really highlights the kind of difficult trade-offs and pressures that started to emerge as the web became this huge commercial platform, not just a research tool.
And that actually leads us right into what he seems to be focused on now, right?
Yeah.
Which feels like a direct response to some of these issues around control, data, and maybe centralization.
Exactly. His current major focus, the big project, is called SOLID.
Solid. Okay, what's the big idea behind Solid?
So SOLID actually stands for Social Linked Data. It grew out of research from his Decentralized Information Group, that DIG group at MIT.
Okay.
And he's even co-founded a company called Inrupt to help build a commercial ecosystem around it.
So what's the goal? What problem is Solid trying to solve?
The goal is, well, it's pretty ambitious. It's to fundamentally change how data works on the web, specifically to give users, you and me, ultimate control and agency over our own data.
Giving users control, how does it actually propose to do that? The current model is, Facebook has my Facebook data, Google has my Google data.
Right, exactly. That's the siloed model. Solid flips that. Instead of your data being stored inside each app's database, Solid proposes you have your own personal data vault.
My own vault.
Yeah, technically it's called a POD, a personal online data store. And this POD, crucially, can live anywhere you choose. You could run it on a server at home. You could use a trusted POD provider. The location is up to you.
Okay, so I decide where my data lives. How do apps, use it then?
So Solid provides a new set of web standards, things like a global single sign-on, universal access control lists.
Meaning
Apps don't store your data themselves anymore. Instead, they request permission to connect to your POD to read or write the specific data they need to function. And you grant or deny that permission.
Ah, I see. So if I try a new photo sharing app, instead of uploading all my photos to their servers, I just grant that app permission to access the photo album stored in my POD.
Precisely. And if you decide you don't like that app anymore, you just revoke its access permission. Your photos, your data, it stays in your POD under your control.
Okay, that is a pretty radical shift from how things work now.
It is. The social aim, as he talks about it, is really a movement towards empowering individuals with their own data, private data, shared data, public data, rather than having companies as the default owners and controllers of it all.
Interesting. And he's also campaigning more broadly for a better web beyond just the solid tech.
Yes, definitely. In 2019, working with the World Wide Web Foundation, he launched the Contract for the Web.
Contract for the web.
Yeah, it's basically a global campaign. It outlines 9 core principles for governments, for companies, and for citizens, too. It's essentially a roadmap trying to protect the web from misuse, things like misinformation, privacy violations, censorship, and preserve its potential for good.
So, still very much hands-on, trying to steer the ship. The sources even mentioned he's an advisor at a social network startup called MeWe.
That's right. Sources list him as an advisor there, which, fits with his ongoing engagement with the platforms and the ecosystem that operate on the web he created.
Looking back at this whole journey, CERN, the invention, the W3C, the foundation, now Solid, it's really no surprise he's received just immense recognition over the years.
Oh, the list is incredible, long and incredibly prestigious. He was knighted by Queen Elizabeth II back in 2004, Sir Tim Berners-Lee.
Right, for services to the global development of the internet.
Yep. And then in 2007, he received the Order of Merit, which is a really special honor. It's a personal gift from the monarch, limited to only 24 living members at any time.
Wow. And he's a fellow of all the top scientific bodies too, right? Royal Society in the UK.
Royal Society, American Philosophical Society, National Academy of Engineering, National Academy of Sciences in the U.S., all the big ones.
And actual awards are just staggering.
Completely. He got the very first Queen Elizabeth Prize for Engineering in 2013, also the Japan Prize, the Prince of Asturias Prize in Spain, the Millennium Technology Prize from Finland, Germany's Die Quadriga Award,
Wow.
the Seoul Peace Prize just recently in 2022. The list goes on.
And of course, the one often called the Nobel Prize of Computing, the A.M. Turing Award. He received that in 2016.
Yes, and the citation for that specifically mentioned inventing the World Wide Web, the first browser, and those fundamental protocols and algorithms that allowed the whole thing to scale up into the global phenomenon it became.
Beyond all the formal honors, he's really achieved kind of a cultural icon status too, hasn't he?
Totally. Time magazine named him one of their 100 most important people of the 20th century.
What did they say about him?
They said he wove the World Wide Web and created a mass medium, and importantly, fought to keep it open, non-proprietary, and free, highlighting that crucial decision again.
Yeah.
He's even shown up in artworks like Peter Blake's updated Street Pepper album cover, and probably most famously, that appearance at the 2012 London Olympics opening ceremony.
Oh, yeah. I remember that. He was sitting at a computer.
Exactly. And he typed out a message, live, which then appeared in huge lights around the entire stadium. This is for everyone.
Wow. Talk about a powerful statement about the web's core purpose.
Right? Just beamed out to billions of people.
The sources had a couple of quick personal notes, too. Mentioned his philosophy is generally to keep work and personal life separate.
Seems so, yeah. And noted his religious views as being a Unitarian Universalist, but also identifying as an atheist.
Okay. And interestingly, didn't the original source code for the web get sold recently as an NFT?
Yeah, that happened in 2021. The original source code files were sold at Sotheby's as a non-fungible token.
For charity.
The proceeds went to fund initiatives that he supports through the Web Foundation and other channels. It was a pretty fascinating, very modern way to fund future work on the web's principles.
Definitely. Okay, so maybe let's zoom out for a second here and try to really synthesize what this deep dive tells us specifically about his impact on, let's say, the world of data management.
Yeah.
How did his work fundamentally change how we handle data?
Well, the first and maybe most profound impact was just the sheer democratization of information access.
Democratization. How so?
Before the web, getting data often meant, logging into specific separate systems, proprietary databases, that kind of thing.
Right, you needed special access, special software sometimes.
Exactly. The web, with its universal browser and its simple linking mechanism, suddenly made vast amounts of data potentially accessible and searchable by anyone with an internet connection. It broke down those silos.
Moving from fragmented systems to a universal information space.
Precisely. It enabled things we take for granted now, like global online databases, digital libraries, accessing scientific results instantly.
And the technical standards he built, HTTP, HTML, URLs, they were the key to enabling that on a technical level.
Absolutely. They formed the bedrock for data interoperability on a massive scale. Different systems, different types of data could suddenly be linked and accessed using these common, open, non-proprietary standards.
So you didn't need custom gateways for every different data source.
Right. The web provided this universal interface. That's what allowed massive distributed information systems to actually work and scale up.
And his later work, the advocacy part, that seems very data-focused too.
Oh, yeah, definitely. His championing of open data through the WWF and especially the Open Data Institute has been a huge catalyst globally.
Pushing governments and organizations.
Pushing them to make their non-sensitive data sets freely available online. That's fundamentally about democratizing access to public information, making data a public resource.
But there's an irony here too, isn't there? By creating this open infrastructure.
He also inadvertently paved the way for the massive explosion in data collection that we see today.
Right. The very infrastructure he built enabled all these new data-hungry platforms to emerge.
Exactly. E-commerce, generating transaction data, social media generating user interaction data, streaming services, tracking viewing habits. The web provided the pipes for data to be generated, collected, and shared at scales that were just unimaginable back in 1989.
Which, as you said, brings us full circle back to Solid. His current work seems like a direct attempt to grapple with the consequences of that data explosion. The privacy issues, the control issues, the centralization.
Precisely. The issues that arose partly because of the architecture he pioneered and its wild success. Solid is his attempt to build a new layer, using linked data principles to put, as he says, data back into the hands of owners, directly addressing the challenges his first invention helped, unintentionally, to create.
So we've traced this incredible story from, a specific frustration among physicists at CERN to this global phenomenon that connects billions and underpins so much of modern life. And now we see the ongoing effort by its own creator to kind of fix its unintended consequences and shape its future path.
It's a really powerful demonstration, isn't it? How one person's insightful work, that connection of existing ideas, could create something so utterly transformative, and then how that same individual continues to grapple with the complexities, the challenges, the responsibilities that come with the world they helped build.
And for everyone listening, the web, in its current form, well, it's the environment you navigate every single day. You're relying constantly on those core foundations he laid down.
Yeah. And maybe thinking about Sir Tim's current focus initiatives like Solid, the contract for the web, this push for user control, for decentralization, for addressing misuse. It leads to a final thought.
Okay.
Consider this. What does the future of your online experience actually look like if these visions, these ideas of a more decentralized user-controlled web really start to take hold?
How would it change things day to day?
Exactly. And maybe even what responsibility do you feel you might have in advocating for the kind of web you want to see in the years ahead?